2.1 is officially vertex form of a quadratic function. Everything in chapter 2 is about quadratic functions. Now, what do I mean by quadratic functions? Quadratic function. What's a graph of a quadratic look like? Do we remember that one? Are we reading it?
Excuse the interruption. Any 7th grader that has not had their picture taken, please report to the main gym. All 6th graders, please report to the main gym for their picture of all 6th graders.
Okay, so when we talk about quadratics, we are going to be going back to the parabolas, okay? The U shape. We did those back in Unit 1 a little bit, yes? Now, I'm going to tell you right now, though, we're not using Desmos to graph these. We're learning all the details and specifics of how to graph them by hand, okay? Also, when we talk about quadratic, anytime we talk about quadratic, it's something where the highest power is x to the second, okay? So when we talk about quadratic, we're talking highest power of x to the second. Now, with that in mind, so a quadratic function is of the form f of x equals ax squared plus bx plus c, and that's as long as a does not equal 0. Only because if a equals 0, it's no longer a quadratic. All the quadratic functions we're going to be dealing with are transformations of the basic parent function f of x equals x squared, which, what's another name for f of x, folks? F of x is the same thing as saying y, right? So the same thing as saying y equals x squared. When we graph these, we're going to be going back to parabolas. So it's back to the U shapes. Now, specifically, the U shape, not the V shape. Okay, and we'll review that. And then what we are specifically going to be looking at in this lesson is the vertex form of the quadratic function. Okay, the vertex form of the quadratic function is this right here. F of x equals a times x minus h squared plus k. Notice it says where hk is the vertex. If you also look at this, hk, x minus h squared and then the plus k, does that remind you of what we did last chapter? It should. Does this chart, it's kind of a scaled down version because I shrunk it in, but does this chart remind you of what we did last semester? Or last semester? Same semester. Last chapter? Okay. So if you recall, last unit we had those green half sheets. This is that same chart, folks. It keeps coming back all year long. I told you that, right? So keep these charts handy is what I would suggest, but we're still going to be talking about these charts, where that x minus h is your translating left or right. Your plus k is your translating up or down. Okay? Now, review. I went ahead and I already have the graph here. Okay, but what are key points on a parabola? When you go to graph a parabola, so like when you have to graph it by hand, or if you have to graph it on the Savas. Okay, what are key points? Where's my vertex usually start out at before we've done any movements? Vertex starts out at 0, 0, yes? And we could fill in 0, 0 right there as well, yes? Okay. What are other points? When we talked about a parabola last 9 weeks, starts at 0, 0. What do you remember, Hayden?
1.
Then the first pair of points go over 1, up 1. So I'm going to list that as 1, 1 here. But keep in mind that would be going over 1, up 1, over right 1, up 1, and then also over left 1, up 1. Yes? Do you remember the next pair of points?
2, 4.
Yeah. Okay. So it's coming back to us, yes? First set of points go over 1, up 1. Second set of points go over 2, up 4. These are the set of numbers I ask that you remember when you're graphing quadratics. Notice this parabola here. vertex 0, 0. Now, I grabbed this from the book, so the points aren't there, but does it go through 1, 1 on both sides? Right one up 1 and left one up 1. And also, does it go through the 2, 4 and negative 2, 4? Okay. Throughout this chapter, I didn't look, but you will sometimes also have to draw the axis of symmetry. So watch in Savas. If it says draw the axis of symmetry, you have to draw it in, yes? And that's putting in that dotted line. Where's my axis of symmetry here?
0.
Yeah, but we don't just say 0, we officially say x equals 0, because the axis of symmetry is always the first number of the vertex, yes? Okay, our axis of symmetry here would actually be the y-axis, wouldn't it? Okay, so sometimes you will have to draw in that axis of symmetry, sometimes you don't. A few other things, okay? H and K we talked about already as the vertex. The other key piece is the A value, okay? The value of A makes the graph either stretch or compress. Folks, it goes with this A right here that's on our chart, where it's A times f of x. It's either going to make the graph stretch or compress. If A is positive, then the graph opens up. If A is negative, what happens when A is negative? Technically, it's a upside down because a negative is going to reflect it. So if A is positive, the graph opens up. In other words, if that value out front is positive, it opens up. If that value out front is negative, then the graph is reflected and opens down. Okay? If A is a fraction between 0 and 1, so in other words, if A is less than 1, then the graph is compressed. If A is a number greater than 1, the graph is stretched. Okay? I don't know about you guys, maybe I'm the teacher, I know. To me, I feel like some of this is old news. Because I feel like it definitely relates to what we did in Unit 1. Okay? We're just going to really stretch what we know about quadratics from Unit 1, and we're going to grow that knowledge more. Okay. Shall we try and graph some?
Yeah.
Okay. So, if you look at the bottom of the page there, it asks us to do two things. It asks us to describe the transformations of the parent function, f of x equals x squared, then graph the function. So, you have the little, you guys are young, you still have good eyes, right? You can read that. The little shrunk down version there, right? However, you're always welcome to pull out the green papers again. Or maybe you know this stuff by now. So g of x equals x minus 1 quantity squared plus 2. What transformations do you see? In other words, what's being done to x squared? What do you see? What? Okay, well, so here we have x squared, yes?
Yeah.
Anything extra does something to the graph. The minus 1 does something to the graph. The plus 2 does something to the graph. What do they do to the graph? Unless they think green paper.
You're going to go left, right, up, down.
Uh-huh. Left, right, up, down. What's the minus 1 tell me to go?
Do it to the right.
To the right one. Is this coming back to us? So minus 1 is going to tell me to translate right 1 units. Okay. I'm going to write it down in words here in a moment. What's the plus 2 tell me to do?
Y equals 2.
Okay. So it's up or down when it's outside the parentheses. Since it's a positive, we're going to go up. So I'm going to put it down here that we're going to translate. Do Do try and put a verb out there, folks. Translate, shift, move. Okay. Translate, what did we say? We just said right 1 and up 2 units. That was nice. I didn't take off for it on the test, but I do always prefer some kind of verb there other than just right 1 up 2. Okay. Okay, we don't have anything else, do we? Do we have an A value out front here? There's nothing outside of my parentheses, so it's just going to be a normal quadratic. Okay, let's graph it. Where's our parabola normally start at? 0, 0. Where's it going? Up 2 and? Right 1. So I'm going to go right 1, up 2. Could you state the vertex if you had to? I think that's later. I don't have it here. But you could state that vertex if you had to, right? So we moved that vertex right 1 up 2. Now, do I get to just draw any random U and I'll take it? No. With Savas, you probably only have to plot 1 extra point, would be my guess. Usually how the parabola tool works is you plot the vertex, and then you plot 1 other point, and it just automatically makes the parabola for you. So nice. On paper, what am I going to tell you to do? What'd you say? Okay, so from the vertex, my first set of points are over 1, up 1. So I'm going to go right 1, up 1, and I'm going to go left 1, up 1. When we're doing this on paper, I'd like one more set of points, please. Where's my next set of points go? What was it?
Like to side 2 up 4.
Okay, so 2, 4, right? Now, we're not doing this from the origin, right? We're doing this from our vertex. So from this vertex, I'm going to go right 2, up 4, and back to the vertex, I'm going to go left 2, up 4. And then when we connect that, try and make it U looking, right? I know it's so easy to turn it into a pointy V, but it's not. I really don't like my first side of that. There we go. Something like that, yes? Okay. Are we good there? Okay. Think about the next one. Think about what transformations you're going to tell me here.
Yes, I do. Wait, did you say you need a pencil?
I said you have a pencil.
Oh, no, I do not.
You need one.
Yes.
It's your lucky day. There's a whole bunch of choices in here for today. And most of them should be decent.
Danke. Danke.
Welcome.
Yes, see.
Okay. What'd you guys come up with on this one?
You're gonna go to the right 2. Maybe. No. I don't know. Do you gotta distribute that negative? I don't know.
Okay, no, do not distribute the negative. And here's why can't I distribute the negative? Because it's not just a parentheses, but there's an x squared. So we're not going to parentheses. But we're not going to distribute. Think about just that plus 2 right now. I heard left and right. You guys are on the right track because the plus 2 is in the parentheses. So it is. It's left or right. What am I going to say?
Left.
Left because we go left to right opposite the sign. Yes? So we are going to go left 2. Now, what about that parenthesis that I'm vetoing distributing? You reflect it. Yes? Go back to your chart.
Upside down.
Yeah, it's going to make it upside down. So we can think of this 2 ways. The official transformation, which is what we were asked to do here, is to reflect it. So this is negative f of x, where the negative is out front, yes? Negative f of x, that is a reflection across the x-axis. If you go back up top on these notes, what did it say? If A is negative, then the graph opens down. So the fact that A is negative, we can either think of it as a reflect or just the graph opens down. So I'm going to write these out. First of all, I'm going to write out that we're going to reflect across the x-axis and translate. Where did we say we are translating? Left 2 units. Okay. You ready to work on the graph? My vertex normally starts where? 0, 0. Where's it going to go? It's going to go left 2. Does it go any place other than that? No. So there's my vertex. Now, where's my first set of points? Okay. Normally we just say it's over 1, and like last time it was over 1, up 1 from the vertex, right? What's different this time? This parabola needs to open downward, so it's going to go over 1, down 1. So I'm going to go over right 1, down 1, and over left 1, down 1, because I need to do the reflection. And where's the next set of points? Over 2, down 4. Okay? And I don't care how your parabola looks as long as your points are there. That's the thing. I'm always going to be looking for your points. Okay. This is just building on what we did last unit, yes? Okay, it's building. We are going to get to different stuff in this unit, but for right now, that's building. Okay. Speaking of building, let's keep building and do 2 more examples here. So notice this had nothing out front on example A. So it was just a basic over 1, up 1, over 2, up 4. This one had a negative out front, so that just told us to go down. Okay, C. Same section. We're still describing transformations and graphing. So, what are the pieces we see that we need to describe here? Okay, are you guys with her on the right 1, down 3? This is the old new stuff, right? This is what you just did on that last test. So the -1 is left to right opposite the sign. The -3 is up or down with the sign, so that's down. So when I write this out, I am going to write out the right 1, down 3. There's another number here.
2.
Yeah, because, you know, here we have x squared. So right there, x squared tells me this is our parabola. What's that 2 tell me out front? Yeah, vertical stretch. Okay. If you go back where we were talking about A, if A is a number greater than the 1, then the graph is stretched. Didn't we also have that on our green paper?
Yeah.
This is from last unit, right? So vertical stretch if A is greater than 1. Now do me a favor. Do tell me it's a vertical stretch, not just a stretch. Okay. So I'm going to write this out. that it is a vertical stretch. And do also tell me the factor. Vertical stretch by factor of 2. That does matter. And what did we do? We also had to translate right 1 and down 3 units. Okay. Let's start with our vertex. Where's our graph going?
Right. Down 3.
Right, 1 down 3. So we have a vertex that is 1, negative 3. Now, what would we normally do next? Except not down. We don't have anything telling me to go upside down this time, right? It's all positive. So normally we'd go over 1, up 1, and then we would go over 2, up 4. What's the catch this time? There's a 2. We are vertically stretching this. So we're going to go up steeper. So here's what I want you to think. The normal graph, y equals x squared, the values you just told me were 0, 0, 1, 1, and 2, 4. Okay, that's what you just told me, yes? We're not doing y equals 1x squared this time. What are we doing this time? We're doing y equals 2x squared. So now, my x values are still going to be the same. We're going to go over 1, up something, and over 2, up something. But what do we need to do with the y values?
You gotta double it.
We got to double them. It's times by 2. So what am I going to do with each of these? Times them by 2. Well, 0 times 2, 0. 1 times 2, 2. 4 times 2, 8. So because it's a vertical stretch, I take it he said the wrong number.
He said 4.
Okay.
I said array. I literally was exactly.
Yeah. Because it's a vertical stretch by a factor of 2, you double, you multiply by 2 what you would normally go up. Does that make sense? That's how a stretch works. Is you're going to stretch it, in this case, by double the amount. If that was a 3 out front, we'd be stretching by triple the amount. Okay?
This is the last call for anyone who has not had their picture taken. Please come down to the main gym. Last call for anybody who has not had their picture taken. Please come down to the main gym.
Okay. So we already have our vertex. I'm assuming you guys have all had your pictures taken, yes? Okay. We all have our vertex, right? 1 down 3. Now, normally I'd go over 1, up 1. What are we going to do this time? Over 1, up 2. What you do on the right, you do on the left. Normally the next set of points would go over 2, up 4. Instead, we're going to go over 2, up 8. Sorry. I can't talk when I have to count something like 8. Okay. Again, your goal is to connect the parabola. And make it not a V. Now, as I said, in Savas, you probably only would have to do the over 1, up 2 part if I had to guess. Okay? But on paper, I want you to know a little bit more. Okay, we don't have the technology that automatically graphs a parabola tool, you know, where you can just click parabola and it automatically graphs a parabola shape for you. I need you to know a little bit more. Okay, questions on that one? Okay, guys. Next graph. G of x equals negative 1/2 quantity x plus 2 squared. Okay, notice. Your pencil give out.
Yeah.
Okay, notice we are talking about a parabola because there's the x and the squared, yes? That's how I know it's a parabola. What are the pieces we're going to have to take care of here? Okay, I heard two different things there. The plus 2 in the parentheses. That's left or right opposite the sign. So that is left 2, yes? That's on your green paper. And then did I hear compressed? My a value out front. 1/2. 1/2 is a number that is less than 1, yes? Or between 0 and 1. So this is going to be a vertical compression. What else?
It's gonna be a reflector across the x-axis.
Yeah. There's a negative out here, isn't there? So that means we're going to have a reflection. Okay? So we've got three things going on here. We're going to vertical compression by a factor of 1/2, reflect across the x-axis, and finally translate left 2 units. So vertical compression by factor of 1/2 reflect across the x-axis and what else were we doing? Translate left 2 units. Okay. Once you get all that, think about where's your vertex going to be. Where are we going to move this graph? Left 2. I don't have any other movement or anything else that's going to affect my vertex. So my vertex will be negative 2, 0. Left 2, up or down 0. Now, reflect across the x-axis just means instead of opening up, it's going to open down. What about a vertical compression by a factor of 1/2?
Are you just doing it rise over run?
I wouldn't think of, you can't think about rise or run, or we're going to have a straight line. Okay, we're going to take all of our y values this time and divide them in half. Okay, so I'm going to kind of set up the same way I did last time where, okay, here's your visual. You may not need to write down the originals, but the originals are 0, 0, 1, 1, and 2, 4, yes? We're being asked to graph y equals 1/2 x squared. So again, x values don't change. Y values, you're multiplying by 1/2. What's half of 0? Half of 1? 1/2, 0.5, half of 4, 2. Now, are you okay with graphing a decimal? Not our favorite by any means, is it? Okay. Could you come up with another point if you wanted to? You could. Think about 0, 0 squared is 0. 1 squared is 1. 2 squared is 4. If we continued our original chart here, what would be more points? 3 squared is 9. Do you want to do half of 9? No. 4 squared is 16. Could that work for us? Yeah. So, you could do some of these other options. I'm not saying you can't. Okay? If we do half of this, as I said, we could do half of that. Half of 16, though, is 8. What is half of 9? Why did you guys not want it? 4.5, 4.5. So here's my thing. There's my original. I can do 2, 2, and 4, 8, can't I? Okay. On Savas, if you have to do this, you're not going to want to try and graph 1, 1/2 unless you type it in. So you're going to need to know the 2, 2. Okay, so here was my vertex, right? We're going to go over 2. If you go over 1, it's going to be 1/2. Which way am I going with these? Over 2 and where to? This is a reflection, so I'm going to go over 2 and down 2. You can do this both ways. And then if we want whole numbers, we can also go over 4 and down 8. Over 4 and down 8. Okay. If you wanted to peek at some of the other numbers, over 1 down 1/2, does it fit the shape? It does. Over 3 down 4.5. I mean, I'm not saying you need all those points, am I? Okay. But you have some there. I will say one of the hardest parts of that graph is remembering by the time we get to the end that it needs to be upside down. Maybe that's just a personal thing because I have a big old right side up parabola that I had to white out in my notes. So maybe it's just a personal thing. But I'll be honest, even here, going through this just now, I had to stop and think, oh, hey, wait, yeah, we're reflecting this, aren't we? Okay. I know it's my opinion as a teacher, but these graphs are doable, folks. Okay. Have patience when you get to doing them in Savas. Ask for help if you need help in Savas, okay? I will gladly try and fight. I will more than willing to fight through Savas with you. Okay? Might be able to give you some tricks along the way or tips, but be ready. Okay. Bottom of this page. And by the way, we will be finishing these notes tomorrow because there is a third side also. So we will be finishing notes tomorrow. But let's see what we can talk about here. The title, part of the big thing today is key features of a quadratic function. Okay? When we talk about these key features, okay, some of this stuff was already listed. The vertex form of a parabola is of the form f of x equals a times x minus h squared plus k. That was mentioned on the front side, yes?
Yeah.
Vertex is hk. That was listed on the front side. Axis of symmetry was not, but what did we learn a while ago? The axis of symmetry is the first number in the vertex, yes? Okay. You've got to know that, folks. Now, a little bit of new information. The vertex of the parabola is either the maximum or the minimum of the graph. Do you guys know what we mean by maximum and minimum?
I think that's the highest or lowest.
The highest or lowest point, right? So the vertex is either the maximum or minimum. If it's a maximum, that means the parabola is upside down and it's the highest point. If it's a minimum, the parabola is right side up and it is the lowest point. So when you're asked to identify the maximum or minimum, you just have to know, is my parabola right side up or is it upside down? Domain. Okay, domain is back. The domain of the parabola is always negative infinity to positive infinity, which means all real numbers are included, because domain, folks, this is a review for the test. Domain is how far left or right my graph goes. How far left does a parabola go? As it's going up or down, it's going infinitely left and infinitely right. So negative infinity, positive infinity. The range of the parabola, that's the up and down, and that's based on the min and the max. Okay? If your parabola has a minimum, your range is going to be that number and everything above. If your parabola has a maximum, it's going to be that number and everything below. Okay? So that's what we're going to be practicing on. Now, I bet there's some of these in Savas, so I apologize ahead of time for your frustration. But the only thing is how many things are they asking me to identify here? So, are you likely to see a 5-part problem in Savas? Yes. Okay. I'm telling you up front, okay? However, I think you'll be a little more prepared than last time we saw a big part problem, and I think it'll be very doable. I guess we're stopping here, aren't we?
I guess so.
So we'll start tomorrow, and we'll kind of pair this up with the idea of f of x equals a times x minus h squared plus k, and we'll go from there. Remind me if I forget where we left off tomorrow. Tomorrow we'll finish that page and the next page. You might have some work time tomorrow. I'm not going to guarantee it, but I feel like you might.